And with that, Konstantin, I'd love to invite you up to start us off.
1, 2, 1, 2. Thank you, Ellie. Hello, Hacker House Solana. Hello. My name is Slides. My name is Konstantin, and I am CEO of Neon Labs. And question to you, how many of you are Rust developers? Raise your hand. Rust developers? Rust developers? And how many of you Solidity developers? Do you have any Ethereum guys in the Solana Hacker House? Okay, so for those of you who are coming from the Ethereum world, just a second. How it changed? Okay, so we are Neon Labs team. We're more than 45 people coming from around the world. And almost 2 years ago, we decided to do the following. We decided to unify two different worlds. The world of Ethereum, the most popular, so many dApps, developers, and the platform itself from 2015. And from other hand, fast-growing, powerful Solana network with the power of and transaction per second, networks, new community, different people, different culture. And this was the reason for Neon Labs to be born. As I mentioned before, we decided to unify two different worlds. Ethereum, proof of work, proof of stake is coming, and proof of history, and the different approach of the Solana into the one approach. And why? Many different dApps from the Ethereum world really would like to join Solana and to join liquidity of Solana. And you guys, you build something on Solana and gamify, DeFi, different NFT projects, and you would like to combine and join and unify forces with the Ethereum world. For the Ethereum guys, for those who build different smart contracts on Solidity, once they start deal with Solana, it's usually a lot of obstacles. What does it mean? Ethereum is kind of Solidity language, JavaScript, much more easier. And when they're coming to the Rust, okay, no copy-paste, C++ basics, and it's totally different. And it's not so cool and not so easy for the Ethereum to join Solana. And this is how our team came with the idea how to unify and build the platform, actually build the solutions that make it possible for any Ethereum dApp to work with the Solana natively. And how we did it. I will show the architecture in a couple of minutes and we will show the demo. We created a smart contract, a programmer on Solana that knows how to take transaction, Ethereum-like transaction, and to run it natively using BPF instructions on the Solana natively. So we made programmer smart contract, EVM, written in Rust and run natively on Solana. And as I mentioned before, two different worlds. For example, the size of transaction in Ethereum actually limited by the gas price. In Solana, when we talk about the transaction size, it's 1,232 bytes. And so many differences. And it means I just can't send Solana transaction or Ethereum transaction using RPC into the Ethereum. And this is how we actually created. We created the proxy server. Actually, this is the EVM also. And the proxy, and the role of the proxy to accept any Ethereum-like transaction. As you can see, we have EVM also inside the proxy. The role of the EVM, actually the proxy knows how to parse, to convert Ethereum transaction into Solana time transaction. It takes a nonce, it takes addresses stored in the Solana, send transaction to EVM, get all the necessary accounts, a list of all the accounts necessary for the running this transaction into EVM on proxy, run emulator to do estimation of the gas for the Ethereum-like, and actually we start work with the Solana. In other words, the proxy takes, for example, one big Ethereum transaction, split it on different chunks. For example, if Ethereum transaction much bigger than the Solana standard, and it starts sending packing and starts sending to EVM, to Solana, to our programmer. It will be invoked each and every time and actually executed using the power of Solana. Again, Neon proxy takes, parse, it knows how BPF instructions will be required for each and every transaction, and it packed Solana transaction and send it to the Neon EVM. As I mentioned before, in most of the cases, we will need to split transaction to a number of transactions Solana, and it means the proxy will work in the iterative way. So it sends some piece of data to the Neon EVM. The programmer invoked, execute number of BPF instructions that was accepted from the proxy itself, and store and save the result of this execution into the storage of Solana. How it works actually? The bytecode, the smart code, the compiled smart code of the Ethereum actually stored inside the Solana storage in the bytecode format. It means since the EVM we created in the Rust, it knows how to work with the bytecode natively. It means that Solana validators will execute everything and the Ethereum code itself will be run natively on Solana. So, as I mentioned before, depends on the size of the Ethereum transaction, it will run in the iterative way of the transaction to natively on the Solana, and after all, the result will be sent back to Ethereum, to the Ethereum dApp. Another approach, as of course you know, Solana knows how to run and execute transactions in the parallel. Actually, we can use the same power for the Ethereum-like transaction, but only in cases if the execution requires number of smart contracts, Ethereum smart contracts that not depends one on each other. Actually, we can use the power of Solana to run Ethereum transaction in the parallel using parallel processing. Now our team works on the new functionality to use optimistic approach to use the full power of parallel processing on Solana in the work with the Ethereum transactions. Another thing, many Ethereum dApps, and we have big pipelines that already wait for our mainnet. We're still on the devnet, we're on the testing stage, pre-order mainnets that will come in the close future. Most of the dApps say, okay guys, Solana is cool. Some of them, Ethereum maximalists, they can argue, but again, they don't understand the power of Solana, the growing power of Solana, and the growing ecosystem. They want, okay, this is interesting. This is new ecosystem. We really want to be part of it, and especially about liquidity. And we actually created also necessary wrappers to make it possible for ERC20 Ethereum tokens to be compatible with the SPL tokens on Solana. And the wrapper actually make it possible to do interoperability of the assets between Ethereum dApps and the Solana dApps. If you want to move, for example, your assets from the Ethereum world to the Solana, you can use Wormhole, actually the sponsor of this hackathon, and you can send ERC20 and you will get SPL, and this type of SPL token you can move to the Neon also. And in the close future, it will be available and possible to move directly your assets to Neon also, and we work with the Wormhole these days. About Neon, why decentralize? And the DAO will govern all the processes and voting and everything for the mainnet, for the IDO, for everything. And proxy itself, proxy will be not managed by our team, it will be decentralized also. Each and every of you can operate this proxy to be operator and to accept transactions from the dApps, from the Ethereum-like transaction from the dApps, take Neons, the token, the utility token, for the managing this transaction, and actually the operator will pay in Seoul to the Solana validators, and half of these payments it will be sent to to the Neon EVM governance. If you're coming from the Ethereum world, use MetaMask or you use Truffle or Hardhat, and we will show the demo. Everything works. You can deploy your smart contract smoothly, and each and every transaction that you will send to the Neon platform will be, as I mentioned before, run natively on Solana. Okay, this is your hackers, and we will show the demo how to use, actually how to deploy Ethereum smart contract, and it will be run on Solana. And our developer Ivan is going to present on Zoom. Please help us to bring Ivan.
Hello guys, hello Hacker House, hello Seoul. Hello Konstantin, thank you. My name is Ivan. I'm a software engineer at Neon Labs, and now I will present you a short demo of how you can deploy your smart contracts written in Solidity directly to Solana. By following this link, you can find our examples repository. I will give you a couple of seconds to take a picture.
Ivan, just a second. We're going to bring you on the screen. Just a second. Just a second.
I'm waiting. Is it all right?
Not yet, but hackers can scan your QR code for the demo. Wait a minute.
Okay. So?
Not yet.
Can I continue?
Not yet. The transaction is still waiting. Wait, Ivan. No. Zoom.
Yeah, Zoom. This is share screen.
Go.
Okay, Ivan. So we can see your presentation demo, but we can see your browser. Yeah, please continue.
Okay. In this repository, you can find out several examples. Currently, you can use examples named simple ERC something. We have 3 project templates for Python Brownie, Hardhat, and Truffle. So you can use all your preferred tools and use these projects as templates for your configuration. Basically, you just need to change a couple of lines in configuration of Hardhat to make your existing project to work with Neon. I will show you a little bit details. Here we can find Neon Labs network configured, and for this network we set up our proxy devnet solana org/solana, and network ID, which you also can find at chainlist.org, and import network settings to your MetaMask. But today I'm not gonna show you these professional-like tools. I will show you how to deploy smart contracts using Remix. It's much easier to understand. And first of all, I will show you settings of my MetaMask wallet. I'm using network called DevNet Neon. Here you can find the same proxy RPC URL and the same chain ID as in configuration files and examples repository. Currency symbol is Neon, and my balance currently is 0. What I'll do next, I'm gonna go to the site called neonfaucet.org. This is our testnet faucet site where you can drop any tokens that we support currently on DevNet. We support Neon, our native token, and several other tokens. Keep in mind that they are not real. This is just test tokens. You can drop any of them. I will connect my MetaMask wallet. I will refresh, connect. Go to MetaMask, connect. Yes, I have 0 balances. It is a clear account. I will select Neon token and drop 100. 100 is the maximum amount. And after first airdrop, you will wait for a minute. Go to MetaMask, make sure that tokens obtained. Yes, they are. I have 100 neons on my MetaMask wallet. And now I'm going to go to Remix. Here I have a pretty simple project. I have only 2 files. irc20.sol. This is a definition of irc20 interface. Nothing special, just default functions. And I have the implementation of this interface in a file called test irc20sol, contract irc20, and it is irc20. It inherits in the irc20 interface. So implementation is pretty simple and dummy. There is no checks, no restrictions, just pure transfer. Pure approve, transfer from function, mint, and burn. Now I'm gonna compile. Actually, they are already compiled, but just do it again. Compile. Go to deploy section. Select in environment here injected provider MetaMask. Make sure that I'm using right account. This is my account with 1,100 of neons, but Remix don't know that they are neons. This still shows Ether. And I'm gonna deploy test irc20.sol. Click deploy. Click confirm. Yes, token is deployed. Now I can go back to my MetaMask, and we can see that balance is decreased somehow because of a fee for deployment transaction. And now I'm going to take this address of my token. I'm going to copy it and import this address as a token into MetaMask. Click import tokens, and here name of my token is TRC20. It has 9 decimals. Add custom token. Currently, I have only 0 TRC20s. Import tokens. And now I'm gonna mint some tokens to my MetaMask. I'm gonna copy address of my account. Check out signature of mint. We should just pass amount of tokens to mint function, and they will be dropped to sender balance. Sender is my MetaMask. I'd like to obtain a lot of them. Actually, here we have a gray amount, so that's why I'm using so many zeros. Click mint. Confirm in MetaMask. Yes, transaction finished. Go to my assets, and now I see I have 100 TRC20s. Next, I'm going to show you how the tokens could be transferred between accounts. We'll create new account, account 38, create, wait for a while. Just refresh MetaMask. Great. I'm not gonna connect this account to Remix. I will just import my token to my new account. Import tokens. Here it is. TRC20, 9 decimals, add custom token, 0 tokens again, because it is another account, import tokens. And now I'm going to transfer my tokens from my account 37 to my account 38. I'm going to copy this address, switch back to account 37, go to my token, and click send. Insert address of my second account, write down amount of tokens. Next. Great. Confirm transaction. Transaction is still pending. Wait for a while. Yes, it is confirmed. Now I can see I have only 85 TRCs on my first account. I will switch to account 38. I'm not going to connect it to Remix. And now I see here 15 TRCs that was received from my first account. So that's how it is simple.
Okay, Ivan, can you hear me?
That's it. Thank you.
Ivan,
Yes.
a lot of Ethereum. Can you show us on the Neon scan how it looks like inside the Solana?
In the Neon scan. Okay, let's look. Yeah, we have our explorer called the neonscan.org. Probably this is my transaction. I will check. It was sent from DC36. No, it's not it. Okay, I will copy transaction ID from here and try to find it here. Yes, here is my transaction.
And Ivan,
you can see this is my first account.
Ivan, how it looks like in the Solana scan?
In SolScan, we have only one corresponding Solana transaction behind this Ethereum transaction. In the SolScan, it looks like this. SolScan actually is pretty slow. I will use Explorer. I just copied this transaction signature, pasted here. We are not on mainnet beta, we are on DevNet. Here it is.
Good.
This transaction. And here we can also find transfer. No, it's not SPL token blocked. We have some transfer, it is fees. And I created new account inside the Solana transaction. This account is a balance account for SPL for ERC20 token.
Okay, Ivan, thank you so much.
That's how it works.
Yeah, thank you so much.
Thank you.
Thank you, Ivan. So, we're still on the DevNet. We're pre-or mainnet platform, and we're in the middle of security auditing, different testing. And as I mentioned before, two different platforms, so many incompatibilities, where the professionals in the Rust and in Solana programs and developing in the Solana ecosystem. From other hand, so many things to do with the Ethereum. If you are coming from the Ethereum world, and you want to get fast track to the Solana, and you want to test your solution, you can take a part in this challenge, deploy your smart contracts, or to develop a new platform, or to fork any blue chips, Aave, Curve, Sushi, any Ethereum dApp solution, and to test it on our platform. If we will find some bugs and showstoppers, you will get some prizes from us, because this is for us the most crucial part, is to test, and be ready for the mainnet that is coming very, very, very soon. This is the challenge. If you would like to take a part, you will see the QR code. I'm here on the venue. Our developers will be online for you also. So if you want to take part, fast track from the Ethereum to Solana using Neon, and we're here. And good luck with your hacking. Thank you very much.